Uh, okay. So I'm going to share the screen. Okay, so today we are going to solve the problems from the problem set on the fins. That is module 1.3. Okay, so okay, this is the problem set that I have already given to you, and in fact, in the yesterday's lecture, we have already solved problem number 1 and problem number 3. Okay, now we will solve the remaining problems from this problem set on this fins. Okay, so let's start. I've already told you the clear instruction. Okay, so if my voice is not clearly audible and if the screen is not clearly visible, okay, so please unmute yourself and please inform me immediately so that the corrective measure can be taken immediately. Otherwise, it is difficult to understand that whether you are receiving the proper audio and video quality in the online mode. Okay, now let's see. So first of all, okay, my question is, can you see my screen properly? Anyone please confirm?
Yes, sir.
Okay, okay, fine. Okay, so let's solve. Okay, so problem 1 and problem 3 we have already solved in the yesterday's lecture. Now let's solve the problem 2. Okay, this one. So read the problem. Two long rods of the same diameter, one made of brass having thermal conductivity 85 watt per meter degree Celsius and the other made of copper. Thermal conductivity is given as 375 watt per meter degree Celsius. Have one of their ends inserted into the furnace. Now both the rods are exposed to the same environment. So okay, now at a distance 105 mm away from the furnace end, the temperature of the brass rod is 120 degrees Celsius. Okay, now the question is at what distance from the furnace end the same temperature would be reached in the copper rod. Okay, so this is the problem. Now on the basis of the statement given in the problem, first of all, we will draw the sketch. Okay, so things will be more clear and then we will proceed. Okay. Now, okay, so this is the problem set. Okay, on fins. Okay, now this is the problem 3. Sorry, problem 2. 1 and 3 we have already solved. This is problem 2. Okay, so two long rods are there having the same the diameter. So first of all, we'll draw the diagram. Two long rods are there. So you can see this is suppose this is a wall. Okay, this is a wall. Okay, and we have taken two long rods of the same diameter. Okay, one is made up of brass and another one is made of the copper. Okay, so this is a brass rod and this is a copper rod. Okay, what is this? This is the brass rod. And what is this? This is copper rod. Okay, having same diameter. Okay, so that means the cross section is circular. Okay, so two long rods of the same diameter, one made up of the brass, okay, and thermal conductivity is given for this, and the other made up of copper, thermal conductivity is given. Have one of their ends inserted into the furnace. Okay, so have one of the ends inserted into the furnace. Okay, so these two rods, the brass rod and the copper rod, will act as the fins. Okay, now what is given? Both the rods are exposed to the same environment. Okay, so both the rods are exposed to the same environment. So same environment is available here. Now at a distance 105 mm away from the furnace end, the temperature of the brass rod is 120 degrees Celsius. It is given. Okay, so you can see at distance 105 mm away from the rod, the temperature is maintained as 120 degree Celsius. Temperature is maintained as 120 degrees Celsius. Okay. Now it is asked. So at a distance 105 mm away from the furnace rod, the temperature of the brass rod is 120 degrees Celsius. That we have shown. Now the question is at what distance from the furnace end the same temperature would be reached in the copper rod. Okay. Okay. So the question is at what distance from the furnace end the same temperature would be reached in the copper rod. Okay. So suppose we have assumed that suppose at L distance the same temperature is achieved. Suppose okay, so this distance we have to find. At what distance the same temperature? Okay, at what distance the same temperature would be reached in the copper rod? Okay, so that we have to determine. So we have assumed that this L is the distance at which the same temperature would be reached in the copper rod. So we have to determine this length. Okay, so we have assumed that at L distance the same temperature would be reached in the copper rod. Okay, now fine. So we have assumed that this is the we have taken the case 1. Okay, so that is what is case 1? Fin is having infinite length and temperature at the tip of the fin equal to the temperature of the surrounding fluid. Okay, so for this case, okay, that is for the infinitely long fin, है ना? For the infinitely long fin, है ना? Okay, so we have assumed that case fin. Okay, case 1. So what is case 1? Case 1 means fin is having infinite length and temperature at the tip of the fin equal to the temperature of the surrounding fluid. So this we have assumed. So for the case 1, what is the expression for temperature distribution? We will write that expression. Theta by theta naught is equal to, this is theta is T minus TA. Theta naught is T naught minus TA. And it is equal to T to the power minus mx. Okay, so from this we can find the value of T. Okay, from this expression we can find the value of T. Okay, so we can write the expression for T as T is equal to TA plus T naught minus TA into e to the power minus mx. We'll get this expression. Now we will write this expression for brass rod and then we will write this expression for copper rod. So let's write this equation for brass rod. So T temperature for the brass rod is 120. Okay, 120. Now TA, we don't know TA, but the same environment is there for both the rods are exposed to the same environment. Plus, okay, we don't have know the value of T naught also. It is not given in the problem. So T naught minus TA into e to the power minus m. And what is x? At 105 mm distance, the temperature is 120 degrees Celsius. So 105 mm means minus, sorry, the 105 mm means 0.105 meters. 0.105 meters. So this is the equation we have written for brass rod. Now we will write the equation for copper rod. Okay, so we have to find at what distance the same temperature would be reached in the copper rod. Okay, so temperature is same. So we'll write 120 is equal to TA plus T naught minus TA into e to the power m into L, because we have assumed that L is the distance at which the same temperature would be reached in the copper rod. Okay, so this will be m into L2. Okay, so now let's differentiate this. Okay, so for the copper rod, we will assume that this m
So it
is
would be L, e raised to m into L. What is L?
yes,
It will be L, right? L, e raised to m into L.
yes, m into L. Fine. Hello,
Yes, sir. Yes, sir.
am I audible? हाँ
Yes.
हाँ. Okay, so अभी यहाँ पर हम differentiate करेंगे. Okay, so for when we have written the equation for the brass, okay, so we have taken this as m1. ओके m1 इंटू, और ये जो टेम्परेचर 120 कितने मिल रहा है अपने को 105 mm डिस्टेंस पे, so 0.105 meters. Okay, now we have written the equation for this copper rod. So the same temp, yes
सर सर वो
हाँ
माइनस एम इंटू एल आएगा ना कॉपर के
नहीं,
लिए?
हाँ वो माइनस है ना, अभी मैं लिख रहा हूँ, सेकंड इक्वेशन ही पूरा लिखा नहीं है, उसमें मैं अभी करेक्शन का वो लिखने वाला हूँ, उसको हम m2 एज्यूम करेंगे. आई विल राइट दिस. Okay, for this brass, I've written this 120. Okay, this equation we got. We are getting this 120 degrees Celsius temperature at 0.105 meter distance. Okay, now we will write the equation for the copper rod. Okay, so same temperature at L distance. We are at what distance? So we have assumed that at L distance the same temperature would be reached in the copper rod. Okay, so we'll write this. So here in the copper rod, I have assumed this as, okay, so this is Ta plus T naught minus Ta e to the power minus, this is m2 into L. Is it okay? Hello? Fine. So we have written this equation for this copper rod. Fine. Now you can see T naught and Ta are same for both the rods. Okay, T naught and Ta are same for both the rods. Okay, so we will compare this. You can see this is 120, and this is equation for brass rod, this is equation for copper rod. Now this is 120, this is also 120, so we can equate this, and we know if the T naught and Ta are same for both the rods, so we can say this uh, e to the power minus m1 into 0.105, it is equal to e to the power minus m2 into L. Fine. Now you just take the log on both the sides. So I can simply write this as minus m1 into 0.105 is equal to minus m2 into L. Is it okay? From this, minus and minus will cancel. So I can say this, we are interested in L. We have to determine L. So L is equal to m1 by m2 into 0.105. Okay. Now we have to find this ratio m1 by m2. So we know this m1 for the brass rod. Okay, so it is equal to root ph by ka. We know this. Fine. So here the thermal conductivity for the brass is something different. So we will say this as K1 for the brass. Okay, and this M2 will be equal to, for the copper rod, this is pH by K2 into ACS. Okay, this is the thermal conductivity for the copper. Now, just take the ratio. So I can say this M1 by M2 is equal to root K2 by K1. Okay, so here just find the ratio M1 by M2 is equal to, what is the thermal conductivity of this copper? क्या दिया हुआ है thermal conductivity copper का 375 और brass का that is this is K2 and brass का जो है that is it is given as 85, that is K1. So it is root 375 divided by 85. So you just find this square root of 375 divided by 85. You will get this as 2.1. 2.1. Now put the value of this m1 by m2 in the above equation. This one. So you will get L is equal to 2. m1 by m2 का वैल्यू कितना आ गया 2.1 into 0.105. So the calculated answer is 0.22 meters. Okay, that means L is equal to 0.22 meters. So this is the distance for the copper rod. The same temperature 120 degrees Celsius would be reached. Fine. So fine. So 0.22 meters is the distance from the furnace, and the same temperature would be reached in the copper rod. Okay, so we have solved this problem. Clear? Any doubt in this problem? So can I go ahead? Okay, so now okay, so we have solved the second problem. Now let's first problem and third problem we have already solved in the class yesterday. Now let's solve the problem 4. Read the problem. I'm providing you 2 minutes for this. Read the problem and then try to solve the problem. Okay, so let's solve the problem 4. Let's see. The problem 4 is a carbon
सर
steel. हाँ,
सर इसमें वो केस 3 यूज होएगा क्या, क्योंकि हीट डिसिपेशन है।
कौन सा
केस 3
इसमें
यूज
first
होएगा।
this question 4.
यस यस सर।
Okay, so let's see. Carbon steel thermal conductivity is given. Equilateral triangular cross section is given. It is attached to a plane wall which is maintained at temperature this. Surrounding temperature is given as this, and the unit surface conductance is given as this. Now compute the heat dissipated by the rod. Okay, so you can see here the length is given 80 mm long. So we can't use case 1. Okay, because the case 1 is fin is having infinite length and temperature at the tip of the fin equal to the temperature of the surrounding fluid. So we can't assume case 1. We can assume either case 2 or case 3. Okay, so case 2 is okay, so we can assume case 2. Okay, and I already told you that the cases will be the cases will be clearly given in the problem itself. Okay, and then you have to follow that. And if it is if the case is not given in the problem, then we have to assume the most suitable case. Okay, we have to assume the valid case that should be most suitable, and we have to clearly mention our assumption, and then we have to solve accordingly. But mostly the cases will be given in the problem itself, and we have to solve the problem by taking that case only. Then only we will get the full marks for the question. Okay, if some case is mentioned in the problem and we solve the problem and we are solving the problem with some other case, then we will get 0 marks. Okay, so we can assume case 2. So let's solve the problem. फिर से देख लेते हैं. Carbon steel thermal conductivity is given.
Sir, can you speak louder?
Yes, now am I audible?
Yes, yes, sir.
Carbon steel thermal conductivity is given. Okay, with a cross section of an equilateral triangle. Okay, here the cross section, this fin is having triangular cross section, and each side is 5 mm. That means this is an equilateral triangle, and the length is given as length for this rod is 80 mm. So it is attached to a plane wall which is maintained at a temperature of 400 degrees Celsius. Okay, fine. Now the surrounding environment is at 50 degrees Celsius, and the unit surface conductance is given as 90 watt per meter square degree Celsius. So this is the value of H. Now we have to find Q. That is compute the heat dissipated by the rod. So we have to find Q. Fine. So let's solve. So this is the problem 4. Now this is the case. So let's see. Each side of the cross section is given as what is given. We will write this. Suppose I have assumed the side of the equilateral triangle is A. So A is given as kitna diya side 5 mm. Okay, that is it is equal to 0.005 meters. Length is given as 80 mm. That means it is equal to 0.08 meters. Abhi, what is given? It is attached to a plane wall which is maintained at temperature 400 degrees Celsius. So that means 400 degrees Celsius will be our base temperature. That is the maximum temperature. Surrounding temperature is given as 50 degrees Celsius. So TA is 50 degrees Celsius. And the convective heat transfer coefficient is given as 90 watt per meter square degree Celsius. The thermal conductivity value is given as 54 watt per meter degree Celsius. Fine. So this is given. Now to find what we have to find, we have to find Q. Okay. Now let's see the situation. Situation is like this. Okay, so let's solve the problem. Situation is like this. This is the case here. The wall is there, and okay, so this is a wall, and this steel rod is attached to it. Okay. Now you can see here. Here some. So definitely here the base temperature is there. So base temperature, the maximum temperature will be there. That will be T naught here, and here in the surroundings is surrounding temperature TA. Okay, now the length of this rod is L. Okay, this is the length of the rod, and remember the cross section is triangular. Okay, this cross section of this fin is triangular. Okay, cross section of the fin is triangular with side A. Okay, so case 2 we have taken. So for case 2, that is fin is having finite length and insulated at the tip. So for this case 2, okay, fin is insulated at the tip. Fin is having finite length and insulated at the tip. What is the formula for calculating heat dissipation? Very simple. Very simple. Q is equal to, just apply the expression, root, just a minute. एक्सप्रेशन लिखिए उसका Q का सेकंड केस के लिए. रूट PH KA into T naught minus TA into 10 hyperbolic ml. Into 10 hyperbolic ml. Okay, Q is equal to root PH KA into T naught minus TA into 10 hyperbolic ml. Now we'll calculate all these values. So we have to calculate M. Okay, M we have to calculate. Okay, so there are different ways. So two formulas are there. So you can use either this formula, root PHK T naught minus T into 10 hyperbolic ml, or you can use the another one. We have simplified. We have put the value of M. Okay, if you don't put the value of M, so the formula can be like this. Q is equal to KA M into T naught minus TA into 10 hyperbolic ml. अभी m का वैल्यू क्या है? m इज इक्वल टू रूट ph बाय ka. देखो ये एक्सप्रेशन है हमारा q का. अभी m is equal to root ph by ka. If we will put the value of m here, then we will get this expression, the above one. So either you use this expression or you use this expression. The same thing. Fine. चलिए सॉल्व कर लेते हैं. अभी क्या है, पुट करो, वैल्यू पुट करो और कैलकुलेट कर लो वैल्यूज. तो m is what? m is root ph by ka. Now what is perimeter? Our perimeter is, it is a rod having triangular cross section. So perimeter will be 3a. A is the side. What will be the cross sectional area? Cross sectional area क्या होगा? Half into base. Base is a. Height कितना हो जाएगा? Find कर लो. Root 3 by 2 into a. Is it okay or not? The base जो है, okay, half base into height. So this is the base is a. Height कितना हो जाएगा? We can find. Okay, this will be a by 2. है ना, यहाँ पे कट होगा. So apply Pythagoras theorem. So a square plus a by 2 whole square plus this h. This is h. Can find. ठीक है ना, ट्रायंगुलर कैसे फाइंड किया हमने ये? तो you just see here. I apply this as the Pythagoras theorem. This is a square is equal to, this will be a by 2. A by 2 whole square plus this is height. Suppose, okay, तो height को I have taken this as capital H. So this will be a square minus a square by 4 is equal to h square. Therefore, h square is equal to 4a square minus 3a square. So 4 square minus a square, that is 3a square divided by 4. Okay, so h will be what? So h will be equal to root 3a divided by 2. So this we got. Okay. So okay, so now cross section area will be what? Half the base is a into height is this root a by 2. Root 3 a by 2. Okay, so क्या हो जाएगा cross section area? Half into base into height. So half base है a, so half into a into height है root 3 a by 2. यही मैंने लिखा है, half into a into root 3 a by 2. इसको कैलकुलेट कर लो, इट विल बी इक्वल टू रूट 3 a square divided by 4. Okay, now we can find the value of perimeter divided by cross sectional area. So perimeter is 3a divided by cross sectional area is root 3a square by 4. So this will cancel out a, and this I can write as root 3 into root 3. So 1 root 3 will cancel. So it will be equal to 4 root 3 divided by a. So it will be equal to 4 root 3 divided by a. A side कितना दिया हुआ है? Side is given as 0.005 meters. 0.005 meters. Now you just calculate this. So the calculated value is 1386. Okay, so let's calculate m. M is equal to root ph by ka. Okay, so this p by a we have already calculated, so we have to put the value of h. H कितना है अपना 90 डिवाइडेड बाय थर्मल कंडक्टिविटी कितना दिया हुआ है, इट इज 54 मल्टीप्लाइड बाय p divided by cross sectional area, so it is 1386. Just calculate this. So calculated value of m is 48.06. Okay, now either you apply this expression or you apply this expression, we can solve. Okay, so let's apply the above one. Okay, तो अप्लाई कर लेते हैं ऊपर वाला. तो q is equal to root ph by root ph ka. तो p is 3a. ओके, कर लीजिए.
सर वो नीचे वाला लिया तो उनको सिर्फ डायरेक्ट फॉर्मूला ही मतलब वैल्यूज ही पुट
हाँ,
करना
फॉर्मूला
पड़ेगा.
पुट कर, हाँ कोई भी करना है, कोई भी कर सकते हो, एक ही चीज है वो, जिसमें सिंपल पड़े वैसा कर लो. आइदर यू यूज द अबव वन और द बिलो वन, क्योंकि उसमें कोई भी फर्क ही नहीं है ना. देखो पहले क्या आता है, ये क्वेश्चन आता है के एम टी नॉट माइनस टी इंटू 10 हाइपरबोलिक एम एल. हमने क्या किया, एम का वैल्यू पुट कर दिया है रूट पी एच बाय के ए यहाँ पर, है ना. तो फिर फाइनली आपको ये एक्सप्रेशन मिल जाता है अबव वन. ठीक है, तो इस केस में सेकंड नीचे वाला एक्सप्रेशन यूज करने से कैलकुलेशन सिंपल हो रही है, तो ये वाला ले लो, कोई भी यूज कर सकते हो, एक ही चीज है वो, बस एम का वैल्यू पुट कर दिया इस इक्वेशन में. ये इक्वेशन पहले आएगा एक्चुअली, और जब m का वैल्यू ये है, m का वैल्यू हम यहाँ पे पुट कर देंगे इस इक्वेशन में, तो देन वी विल गेट दिस एक्सप्रेशन. ओके, तो चलो नीचे वाला ले लेते हैं, उसमें सिंपल हो जाएगा यहाँ पर कैलकुलेशन. चलिए, सो के एम, सो के का वैल्यू क्या है 54 इंटू क्रॉस सेक्शनल एरिया. क्रॉस सेक्शनल एरिया क्या है, क्रॉस सेक्शनल एरिया हमने ये फाइंड किया है रूट 3/4 ए स्क्वायर. रूट 3/4 ए क्या है आपका 0.005 स्क्वायर. ओके, सो के ए एम, एम का वैल्यू क्या आ गया आपको 48.06 इंटू टी नॉट माइनस टी ए. टी नॉट आपका क्या है 400. टी ए क्या है आपका, टी ए क्या है, सी द वैल्यू, टी नॉट 400, टी ए इज 50. इंटू 10 हाइपरबोलिक एम एल. एम क्या है 48.06 इंटू एल. व्हाट इज एल, एल इज गिवन एज 0.08 meters. 0.08 meters. Okay, that's it. So we have all the values, just calculate this. Okay, just calculate this. So the calculated value is 9.82 and the unit will be watt. Okay, so this is the amount of heat dissipated by the rod. Okay, so we have solved this problem. Okay, now, okay, so we have solved this fourth problem also. Okay, now let's go ahead, we'll solve the fifth one. Okay, fifth problem solve करेंगे. Read the problem. Read the problem. I'm providing you 2 minutes. Just read the problem and start solving the problem. Okay, then we'll discuss and then we'll solve the problem together. Okay, I'm providing you 2 minutes. Okay, so let's solve the problem. Yes, can you see my screen properly? Anyone please confirm? Please confirm. Hello. Can you see my screen properly? Hello.
Oh, yes, sir. Yes.
Okay, fine, fine. Okay, so question 5. Okay, so let's solve question 5.
So can you show the previous question because I was unable because I was having some net issues.
Yes, previous one, na? There's fourth one.
Yes, yes.
Okay, so this is the fourth one. Okay, so this is the problem. We have already solved this problem, fourth one.
Okay.
Ah, the fourth one. Huh? Okay, so what we have done actually in this problem, thermal conductivity of the fin is given, cross section is equilateral triangle. Okay, the side is given, length is given. Okay, so the base temperature is given and the surrounding temperature is given. Okay, convective heat transfer coefficient is given. We have to calculate heat dissipation. Okay, so straightforward formula is there. Okay, everything is given. So we have put this value. The only thing is that this is the fin having triangular cross section. Okay, so we have solved this problem for case 2, that is fin is having finite length and insulated at the tip. So all the values are given. That's it. Straightforward problem. Fine. Okay, you go through it again, and in case of any difficulty, we will solve together again. ठीक है, आप एक बार और देख लेना इसे. ठीक है.
Okay, sir.
हाँ, कोई फिर भी difficulty है, then you tell me, then we will again solve this problem together. Okay. Okay, so problem 5. Okay, so this is the motor body is 360 mm in diameter outside and 240 mm long. Its surface temperature should not exceed 55 degrees Celsius when dissipating 340 watt. So longitudinal fins of 15 mm thickness and 40 mm height are proposed. So the convection coefficient is 40 watt per meter square degree Celsius. Now we have to determine the number of fins required. The atmospheric temperature is 30 degrees Celsius and the thermal conductivity is 40 watt per meter degree Celsius. So let's solve this problem. So in the problem 5, uh, length is given. Okay, so basically in the problem, you can see, first of all we'll draw the diagram.
Sir, case 3 यूज है.
हाँ, केस 3 ले लेंगे, इसमें ले सकते हैं. इसमें केस 3 is the suitable choice here. That is, fin is having finite length and losing heat at the tip by convection. First of all, we'll draw the diagram and we'll try to visualize the situation, then we'll go ahead. So this is a motor body. Okay, this is a motor body. तो ये आपका एक मोटर बॉडी है. एंड देन यहाँ पर क्या लगा हुआ है, इधर here the longitudinal fins are attached. Okay, so here the longitudinal fins are attached on it. Fine. Let's draw the more clear diagram. Just give me a minute. Let's go. बड़ा डायग्राम बनाते हैं, थोड़ा क्लियर रहेगा। Motor body, this is a motor body. Okay, now on the motor body the longitudinal fins are attached. Okay, so let's see the longitudinal fins. Okay, so these are longitudinal fins are attached here. Let's draw the diagram first. Okay, so things will be clear. This is the motor body. Okay, so this is the motor body. Okay, the it is a 360 mm diameter outside and 240 mm long. Its surface temperature should not exceed 55 degrees Celsius. Okay, so now the land you can see here, it should not exceed temperature 55 degrees Celsius when dissipating 340 watt heat. Okay, so longitudinal fins of 15 mm thickness, 40 mm height are proposed. Fine. So you just see here, what is this? This is the height of this fin. Okay, so longitudinal fins are placed. So this is the height of the fin. This is the thickness of the fin. Okay, and this is the length of the fin. Okay, so the height of the fin is given as this. So we'll show this height. Height of the fin is this. So the dimension which is perpendicular to the surface is L. So this is the height. So it is equal to 40 mm. Now the thickness. This is the thickness. Thickness is, we generally take this symbol as Y. So thickness is 15 mm. And the length is given, length of this longitudinal fin is given as 240 mm. Okay, so the dimension which is parallel to the surface, that will be denoted by B.
सर वो केस 3 में फॉर्मूला में वो यूज करेंगे ना, रूट ऑफ पी एच के इनटू एरिया इनटू टी जीरो माइनस टी ए, फिर वो tan हाइपरबोलिक ml वो वाला यूज करेंगे ना?
हाँ, केस 3 वाला फॉर्मूला यूज करेंगे।
सर फिर
केस 3
उसका
में
क्यू का आंसर क्या आया? उसका 21.77 वाट आया।
क्यू का आंसर,
हाँ सर, क्यू का आंसर कितना है उसका?
हाँ 21.77, करेक्ट।
अच्छा, फिर
एब्सोल्युटली
अभी
करेक्ट।
नंबर ऑफ फिन्स कैसे निकालेंगे? मतलब वो टोटल अपॉन करेंगे क्या?
हाँ, करेक्ट। टोटल हीट विल बी इक्वल टू नंबर ऑफ फिन्स मल्टीप्लाइड बाय द हीट डिसिपेशन फ्रॉम सिंगल फिन।
अच्छा, ओके।
है ना, इट्स वेरी सिंपल। देखो, हीट डिसिपेशन फ्रॉम द सिंगल फिन मल्टीप्लाइड बाय द नंबर ऑफ फिन, दैट विल बी इक्वल टू टोटल हीट डिसिपेशन। ओके
सर।
हेलो सर।
हाँ
सर, यश वेट कर रहा है मीटिंग के बाहर, तो उसको प्लीज एडमिट
अच्छा,
कर।
ओके ओके बात ओके। हाँ, ओके। सो दिस इज द डायमेंशन, द लेंथ इज गिवन एज दिस। तो अभी ये लिख लेते हैं हम। इज B, and this B is given as 240 mm. Clear? Now, okay, so this is fine. So ये हमने सिचुएशन यहाँ पर हमने पूरा क्लियर हो गया। अभी यहाँ पर क्या होगा? दिस इज अ बेस टेम्परेचर। तो यहाँ पर बेस टेम्परेचर जो आपका होगा दैट इज टी नॉट, so that the base temperature is given as 55 degrees Celsius. Okay, thermal conductivity is given as, thermal conductivity कितना दिया हुआ है, it is 40 watt per meter degree Celsius. Okay, and here the convective heat transfer coefficient value is given as, this is okay, also 40, this is also 40 watt per meter square degree Celsius. Okay, so this is given in the problem. Now we'll write down these values. So given is, you can say the height is given, that is 40 mm, so it is equal to 0.04 meters. Okay, the length of this longitudinal fin, that is okay, so that the dimension which is so that will be the dimension which is parallel to the surface of this motor body, so that will be denoted by B. So this is 240 mm, so it is equal to 0.24 meters. Now the thickness is 15 mm, so it is equal to 0.015 meters. Thermal conductivity is given, it is 40 watt per meter degree Celsius. Convective heat transfer coefficient is also 40, unit will be watt per meter square degree Celsius. Now the base temperature is 55 degrees Celsius. Now the ambient temperature is given as 30 degrees Celsius. Okay, now the total heat is given as, this is Q total, is given as 340 watt. Okay, so here we can assume case 3. So case 3 is, fin is having finite length and losing heat at the tip by convection. Fin is having finite length and losing heat at the tip by convection. ओके अभी आप लोग अप्लाई कीजिए
सर ऊपर थोड़ा जा सकते हैं
हाँ 1 मिनट एक मैसेज रहा हाँ यस नारायण कैन यू सी
हाँ सर थोड़ा थोड़ा नीचे कीजिए थोड़ा सा नीचे ओके सर
okay so we have taken the case 3. We have assumed case 3 the fin is having finite length and losing heat at the tip by convection. So apply the heat dissipation expression for this. Ultimately we have to find a number of fins. Okay, so we know suppose n number of fins are there, so we know the n number of fins, suppose n is the number of fins. Okay, so number of fins multiplied by the heat dissipation from the single fin will be equal to the total heat dissipation. The total heat dissipation is given, so we'll calculate the heat dissipation from a single fin, so then we will be able to calculate the number of fins. Okay, so for the case 3 we'll apply the expression Q is equal to, apply कीजिए heat dissipation from the fin is equal to root pH Ka into T naught minus Ta into 10 hyperbolic ml plus h by km divided by 1 plus h by km into 10 hyperbolic ml. So this is the expression. Okay, this is the expression for calculating the heat dissipation from the fin for case number 3. That is, fin is having finite length and losing heat at the tip by convection. Now we'll calculate m. m calculate कर लेते हैं क्योंकि यहाँ पर m लगने वाला है इस एक्सप्रेशन में. So m is equal to root pH by Ka. So it is equal to P क्या हो जाएगा 2 times of B plus Y. Okay. Into H divided by K into B into Y. Okay. K into B into Y. कर लीजिए. To put the values 2 times of B का वैल्यू क्या था B is 0.24 and Y is 0.015. ओके. तो B का वैल्यू क्या है 240 mm यानी कि 0.24 मीटर्स प्लस Y is 0.015 मीटर्स है ना 15 mm है तो 0.015 मीटर्स into H. H is 40 divided by थर्मल कंडक्टिविटी कितना है इट इज 40 into B का वैल्यू 0.24 into this Y is 0.015. Okay, so we have put all the values. Now just calculate this. So the calculated value of M is 11.9. Okay, so M is 11.9. Now we'll calculate ml because it is required in this expression above. Okay, unit of this m will be per meter. Now ml will be equal to this 11.9 is m into L. What is L? L is this 40 mm. 40 mm. Okay, so 0.04 meters. meters. Just put the value. So the calculated value is 0.476. Okay, now put all the values in the above expression. So Q fin is equal to root PHKA. Okay, so this P is 2 times of B plus Y. So B is 0.24 meters plus Y is 0.015 meters. Okay, this is perimeter. H is 40. K is also 40. Okay, okay, root pH. Okay, root pH Ka. So cross sectional area. Cross sectional area is B. It is 0.24 into Y 0.015 root pH Ka into T naught minus Ta. So T naught is 55 minus Ta is 30. Okay, into. Okay, यहाँ space नहीं है, so I am continuing this below. So 10 hyperbolic ml, 10 hyperbolic ml. ml का वैल्यू हमने ऑलरेडी कैलकुलेट किया है 0.476 plus h by km. So h is 40 divided by k is also 40 into m. m का वैल्यू क्या था 11.9. ठीक है, आगे का भी वैल्यूज पुट कीजिए. डिवाइडेड बाय 1 plus h by km. h is 40 divided by k into m is 11.9 into 10 hyperbolic ml. So 10 hyperbolic ml is 0.476. ओके, तो हमने सभी वैल्यूज पुट कर लिया. अभी जस्ट कैलकुलेट दिस. ओके, so heat dissipation from a single fin is 21.77 watt. Okay, so this is the heat dissipation from a single fin. Okay, so this is a calculated value of heat dissipation from a single fin. We know number of fins multiplied by the heat dissipation from a single fin is equal to the total heat dissipation. So total heat dissipation is given as 340 watt and heat dissipation from a single fin is given as 21.77. So number of fins multiplied by heat dissipation from a single fin 21.77. Therefore, number of fin is equal to 340 divided by 21.77. It is equal to, calculate कर लेते हैं. Calculate this value. करके बताइए. 340 divided by 21.77. Okay, so the calculated value is 15.61. Okay, so it is 15.61. So we will take the higher number, that is okay. So ये 15.61 आ रहा है आपका. तो number of fins क्या हो जाएगा 16. Okay, so the number of fins is equal to 16. So 16 fins are required for this. Okay, so I've already told you, since we are calculating the numbers. Okay, so 15. Okay, so that means if something is in decimal, so we have to take the higher number. Okay, if it is 15.61, so it will be 16 because the number should be a whole number. ओके, सो ये ऐसा नहीं है कि 15.5 एंड अबव है इसलिए हमने हायर और नंबर लिया है। अगर यहाँ पर है ना 15.1 या 15.2 भी होता तो भी हम हायर नंबर ही लेते, 16 लेते, क्योंकि यहाँ पर हमें नंबर्स कैलकुलेट करना है और वो एक होल नंबर होगा, डेसिमल में नहीं होगा, तो हायर नंबर लेना है। ओके, सम नंबर डेसिमल समथिंग, सपोज 15.1 or 15.2, even then we have to take the higher number, that is 60. ओके, so number should be whole number. ठीक है, इसमें वो रूल नहीं रहेगा कि 0.5 या अबव के लिए हम होल हायर साइड में जाएंगे। इसमें अगर डेसिमल में कोई भी वैल्यू आ जाएगी देन हमको सीधा, जैसे 15.1 या 15.2 भी होता तो भी हम हायर नंबर में चले जाते, होल नंबर में, है ना। हायर, तो विल राइट द हायर साइड, हायर नंबर, ओके, so it will be 16 because number should be a whole number. ओके, तो अभी आप लोग नेक्स्ट प्रॉब्लम, read this problem, next one.
Sir, can you speak louder?
Yes, see this problem, sixth problem. I'm providing you 3 minutes, okay, then we'll solve this problem. Is it okay?
सर इसमें डिटरमाइन क्या करना है? डिटरमाइन Hello.
Problem. Let's see. Problem 6. Turbine blade made of the stainless steel, and it is uh, 500 square is the cross section area and 120 perimeter. Temperature of the root of the blade is 480 degrees Celsius, and it is exposed to the effect of combustion passing through the turbine at 820 degrees Celsius. Film coefficient between the blade and the combustion 320 watt per meter square degree Celsius. Determine.
Sir, your voice is not audible that much.
Yes. Now am I audible?
Yes, sir.
Okay. So okay. So we have to determine. Uh, okay. So in this problem, just write this. ओके सो यहाँ डिटरमाइन के बाद नहीं है तो यहाँ पर लिखिए डिटरमाइन टेम्परेचर एट middle of blade. This is number one we have to find, and the second one we have to find the rate of heat flow from the blade. The rate of heat flow from the blade. Okay, so this we have to find. Okay, so you write this in the question sheet. Okay, ये part थोड़ा मिस हो गया है, क्या find करना है इसमें, this problem. Okay, so turbine blade made of the stainless steel, thermal conductivity is given. It is 60 mm long, 500 millimeter square cross sectional area, and 120 mm perimeter. The temperature of the root of the blade is 480 degrees Celsius, and it is exposed to the product of combustion passing through the turbine at 820 degrees Celsius. Film coefficient in the blade and the combustion gases is 320 watt per meter square degree Celsius. Now we have to determine the temperature at the middle of the blade and the rate of the heat flow from the blades. This we have to determine. That means we have to find temperature and the heat flow. Okay, so this is the problem. So let's solve. So basically the length is given. So here also the case 3 is the suitable. So we'll take the case 3 and we will solve the problem. Okay, now I have yes please all of you please mute yourself. Whenever you have to talk or you have to inform me, then you unmute yourself. Otherwise, there will be some disturbance in the background. Okay, thank you. Okay, I have already told you the problems on the problems on the fins, the case will be clearly given in the problem itself. Okay. So if the case, okay, so the case will be clearly given in the problem itself. So you have to take that particular case and you have to solve the problem. Then you will get full marks. Okay. But okay, and if the case is not given in the problem, then you have to read the problem carefully and you have to take the you have to assume the valid case. Okay, so you have to assume the most suitable case and you have to clearly mention your assumption and then you have to solve the problem. Okay, but uh, mostly the case will be clearly given in the problem itself and you have to take that case and you have to solve the problem, then only you will get the marks. Okay, so suppose if the case is given in the problem and you have solved the problem by taking some different case. Okay, so even though you will get the same answer, but you will get 0 marks. Okay, so so the whatever case is given in the problem, so you have to take that particular case and then you have to solve the problem, then only you will get the marks. And mostly the case will be given in the problem itself. Okay, and sometimes if it is not given in the problem, then you have to take then you have to assume the most suitable case, but that uh, assumptions should be valid. Okay, so you have to take most suitable assumption and then you have to solve. Fine, I've already I had cleared this in the yesterday's lecture also. I've repeated this in today's lecture also. Okay, so please remember this. Let's solve this problem. Is problem 6. Okay, so the length is given. What is given? Write down. Length is given. It is 60 mm, so 0.06 meters. Cross sectional area is given. Okay, so it is 500 mm square, so 500 into 10 to the power minus 6 meter square. Perimeter is given 120 mm, so 0.12 meters. It's a perimeter value. Base temperature is given as 480 degrees Celsius. And in the surrounding, okay, so you just see the problem. The temperature of the root of the blade is 480 degrees Celsius. That means T naught is 480 degrees Celsius and it is exposed to the product of combustion passing through a turbine is 820 degrees Celsius. So in the atmosphere, product of combustion is there that is having temperature 820 degrees Celsius. So ambient temperature is 820 degrees Celsius. Okay, so TA is 820 degrees Celsius. Now thermal conductivity is given. Thermal conductivity is given as 29 watt per meter degree Celsius, and the H value, convectivity transfer coefficient value, is given as 320 watt per meter square degree Celsius. Okay, case 3 taken. Fin is having finite length and losing heat at the tip by convection. Okay, at the tip by convection. First of all, we have to determine temperature at the middle of the blade. Okay, so for this we have to write the temperature distribution expression for this case. So what is the expression, temperature distribution expression? Let's write. It is theta by theta naught is equal to T minus TA divided by T naught minus TA, and it is equal to cos hyperbolic m L minus x plus h by km into sin hyperbolic m L minus x divided by cos hyperbolic ml plus h by km into sin hyperbolic ml. So this is the mathematical expression for the temperature distribution for this case. Now let's put all the values. All the values are given, and we'll find this temperature at the middle of the blade. Okay, so first of all we'll find this m. m find करते हैं पहले. m find करते हैं. Find m.
सर वो x का वैल्यू क्या लेंगे हम लोग उसमें, वो दिया है
x का वैल्यू मिडिल पे फाइंड करना है ना, तो x L/2 हो जाएगा. क्वेश्चन में क्या पूछा है? टेम्परेचर एट द मिडिल ऑफ द ब्लेड. सो L इज द लेंथ ऑफ द ब्लेड, तो मिडिल में लेना है तो उसका हाफ ले लेंगे, इट इज L/2. so x will be equal to L/2. m is equal to root pH by Ka. तो अभी कैलकुलेट कर लीजिए. P कितना है आपका? P is perimeter is also given. .12 h भी दिया हुआ है. Okay, everything is given. Just put all the values. So P is 0.12 into h is 320, K is 29, and cross sectional area is also given. 500 into 10 to the power minus 6. Just calculate this. The calculated value is 51.46, and the unit of m will be per meter. Now we'll calculate ml. ml will be equal to 51.46 multiplied by length. So the length कितना दिया हुआ है? Just see this. Length is 0.06 meters. 0.06 meters. So it is equal to 3.087. Okay, 3.087. Now यहाँ पर सिंपल करने के लिए h by km वाला फैक्टर भी कैलकुलेट कर लेंगे. Then we'll put all the values in this expression. So things will be more clear and simple for making calculation. We'll calculate h by km.
सर थोड़ा ऊपर जा सकते हैं?
हाँ.
नहीं सर, मतलब इसी सेकंड वाले इसका ही 12th स्लाइड के टॉप पे. ओके, हाँ
ये ठीक है ना? हाँ.
ओके सर.
h by km. So h क्या है? h is 320, k is 29, और m क्या है? 51.46. सभी वैल्यूज हमने पुट कर दी. जस्ट कैलकुलेट दिस. So calculated value is 0.214. Now we have to find the temperature at the mid plane. So x will be equal to L by 2. Now let's put all the values in the expression. So T at x is equal to L by 2 minus TA divided by T naught minus TA, and it is equal to cos hyperbolic. अभी देखो यहाँ पर वैल्यू पुट करो, x is equal to L by 2 ले लो, तो ये क्या हो जाएगा, L minus L by 2, so that is L by 2. So this will be cos hyperbolic ml by 2. यहाँ पर भी sin hyperbolic ml by 2. Okay, cos hyperbolic ml by 2 plus h by km into sin hyperbolic ml by 2 divided by cos hyperbolic ml plus h by km into sin hyperbolic ml. So this is the expression. Now you put all the values in this expression. ठीक है, ये एक्सप्रेशन है, हमें इसमें वैल्यू पुट करना. Temperature at x is equal to L by 2, that is at mid plane, that we have to determine TA value.
सर थोड़ा
It is 8. हाँ, yes.
No sir, okay.
Okay, 820. T naught कितना है अपना? T naught is 480 minus TA is 820. It is equal to cos hyperbolic. ml का वैल्यू हमने ऑलरेडी फाइंड कर लिया है. ml इज दिस 3.087 और h by km क्या है 0.214. ठीक है, सो आपका जस्ट वैल्यू पुट कीजिए सभी. cos hyperbolic ml by 2, ml is 3.087 divided by 2 plus h by km is 0.214 into sin hyperbolic ml is 3.087 divided by 2 divided by cos hyperbolic ml is 3.087 plus h by km, that is 0.214 into sin hyperbolic ml, that is 3.087. Okay, now we have put all the values. So so here you can see the we will get just solve this. So we'll get one equation, and okay, so in terms of this T, so we have one equation, one unknown, that is T at x is equal to L by 2. So just solve it. The only unknown is this temperature. So we can find this. So temperature at mid plane will be equal to, the calculated answer is 745.54 degrees Celsius. So this is the answer. Okay, so this is the temperature at the middle of the blade. Clear? Now let's find the heat dissipation. Second क्या पूछे ना, the rate of heat flow from the blade. Calculate कीजिए, कुछ भी नहीं है, डायरेक्टली एक्सप्रेशन अप्लाई कर दो. Q is equal to KAM into T naught minus TA into 10 10 hyperbolic ml plus h by km divided by 1 plus h by km into 10 hyperbolic ml. This is the mathematical expression. Okay, दूसरा mathematical expression भी put कर सकते हैं, m is equal to root ph by ka. So you put the value of m here, so आपको expression मिल जाएगा root ph ka into t naught minus ta into this factor 10 hyperbolic ml plus h by km divided by 1 plus h by km into 10 hyperbolic ml. Okay, now we'll put the values. So heat dissipation, so k का value कितना है 29, cross sectional area it is 500 into 10 to the power minus 6 into m का वैल्यू हमने फाइंड किया था, that is 51.46 into t naught minus t naught is 480 minus 820 into 10 hyperbolic ml. 10 hyperbolic ml का वैल्यू हमने ऑलरेडी फाइंड किया है, it is 3.087 प्लस h by km का वैल्यू था हमारा 0.214 divided by 1 plus h by km, that is 0.214 into 10 hyperbolic ml. So 10 hyperbolic 3.087. ओके, so हमने सभी पूरा वैल्यू पुट कर दिया है. Just calculate this. So the calculated, just calculate this. So the calculated value is minus 253 watt. So this is the answer. Okay, so this is the so we have determined the rate of heat flow from the blade. Okay, so the answer is Q is equal to minus 253 watt. This is the rate of heat flow from the blade. Okay, that is a minus 253 watt. So what is the significance of this negative sign? What does this indicate? The negative sign. Negative sign indicates that the heat flow takes place from the combustion gases to the turbine blade. Okay. Negative sign indicates that the heat flow takes place from the combustion gases to the turbine blade. Okay. Write this. Negative sign is takes place combustion gases turbine. So this was the significance of this negative sign. So okay, so you have to mention the significance of this negative sign also for getting full marks. So let's go to the next problem. 11th one. Figure the copper tube soldered to the plate panel. Okay, this is a steel plate panel. And in the steel plate panel, the copper tubes are soldered. Okay, so this copper tubes are soldered to the steel plate panel 1 mm thick. The tubes are parallel to each other. And kept 450 mm apart. The steam at 100 degrees Celsius, saturation temperature is condensed to water at 100 degrees Celsius passing through the copper tubes. Determine the heat loss per meter length of each tube.
सर
Yes, yes.
तो प्रीवियस सब में वो केस मेंशन नहीं किया था ना सर?
हाँ, इसमें मेंशन नहीं था, हमने
तो
मोस्ट
सर
सुटेबल केस एज्यूम किया।
तो सर जो गिवन डाटा पे हम लोग मतलब केस अज्यूम करते हैं कि थर्ड केस यूज किया अभी।
हाँ, मैंने बताया ना, ज्यादातर आपको प्रॉब्लम में वो केस क्लियरली दिया रहेगा। ओके,
हाँ
और वो केस जो दिया रहेगा वो केस लेके ही आपको प्रॉब्लम सॉल्व करना है ना, तभी आपको मार्क्स मिलेंगे। अगर बाई चांस जो प्रॉब्लम में केस दिया है आपने वो केस नहीं लिया, दूसरा केस लेके प्रॉब्लम सॉल्व कर लिया, तो आंसर भले ही आंसर आपका सेम आएगा लेकिन आपको 0 मार्क्स मिलेंगे। ओके, कोई मार्क नहीं मिलेगा। इसलिए क्या है कि आपको प्रॉब्लम में जो केस दिया है वही केस लेके प्रॉब्लम सॉल्व करना है, और मोस्टली प्रॉब्लम में वो केस क्लियरली दिया रहेगा।
सर
ओके,
अभी तो
अगर बाई चांस
दिया नहीं
अगर
था
बाई
तो
चांस
आपने।
हाँ, अगर बाई चांस कभी कभी है ना, मोस्ट ऑफ द टाइम तो दिया रहेगा, अगर बाई चांस प्रॉब्लम में केस नहीं दिया है, देन यू हैव टू टेक द मोस्ट सुटेबल केस। ओके, तो आपको
सर
बिल्कुल
आपने
वैलिड
वो
केस लेना है,
वैलिड
मोस्ट
केस
सुटेबल केस यू हैव टू। कैसा?
हाँ सर वो आपने वैलिड केस कैसे चूज किया मतलब वो बताओ ना।
नहीं, वैलिड केस ऐसे है ना, देखो लेंथ इज यहाँ पर 60 mm लॉन्ग है, तो देखो फिन इज हैविंग फाइनाइट लेंथ तो है। ओके, तो आप केस 2 पे भी जा सकते थे और केस 3 पे भी जा सकते थे, लेकिन यहाँ पर केस 3 मोस्ट सुटेबल हो जाएगा, क्योंकि केस 3 में फिन इज हैविंग फाइनाइट लेंथ एंड लॉसिंग हीट एट द टिप बाय कन्वेक्शन। ओके, सो वो हम लॉस भी कंसीडर करेंगे, तो फिर हमको एक्यूरेट एनालिसिस मिलेगा यहाँ पर। ठीक है, तो इसलिए हमने थर्ड
ओके
केस
सर।
को यहाँ पर एज्यूम किया। हाँ, ठीक है। तो अगर प्रॉब्लम में केस नहीं दिया है तो आपको मोस्ट सुटेबल, यू हैव टू एज्यूम मोस्ट सुटेबल केस दैट शुड बी वैलिड। ओके, सो यू हैव टू टेक द वैलिड केस दैट शुड बी मोस्ट सुटेबल। ठीक है, अगर नहीं दिया है देन यू हैव टू एज्यूम मोस्ट सुटेबल केस एंड यू हैव टू क्लियरली मेंशन योर assumption एंड देन यू हैव टू सॉल्व द प्रॉब्लम। चलिए, अभी ये वाला प्रॉब्लम हम कर रहे थे। ओके, इसमें डिटरमाइन करना हीट लॉस फ्रॉम पर मीटर लेंथ ऑफ ईच ट्यूब, एंड सेकंड वन इज द मास ऑफ स्टीम कंडेंस्ड पर आवर इफ द पैनल कंटेन्स 25 ट्यूब्स। H of air is given, thermal conductivity of the steel is given, and the air temperature is given. Okay, चलिए आप लोग 2 मिनट का टाइम लीजिए और सॉल्व कीजिए। हम लोग टाइम दे रहा हूँ। अप्लाई द अप्रोच एंड देन विल सॉल्व। Okay, so let's solve this problem. Okay, so let's solve this problem. So you see this here in this problem. This is a steel plate where the copper tubes are soldered. Okay, the parallel copper tubes are soldered, and the distance between the two copper tubes is 450 mm. So due to the symmetry in the geometry of this arrangement of this copper tubes on this steel uh, plate, you can see this half of the distance between the two copper tubes will act as the fin. Okay, इधर ध्यान दीजिए सभी लोग. क्या है? What is this? This is a steel plate. On this steel plate, the number of parallel copper tubes are soldered. Okay, so due to the symmetry in the geometry, okay, so you can see the distance between the two parallel copper tubes is 450 mm. Okay, so you can see the middle point will be the, so at the middle the half distance is there, 225 mm, 225 mm, half of 450. So due to the symmetry in the geometry for the arrangement of this copper tube on this steel plate, this half of the distance between the two tubes will work as a fin. So basically you can say the middle point between the two tubes will be the coldest point, and the temperature gradient at this middle point will be 0, and half of the distance between the two tubes will act as a fin. So for a single copper tube, two fins will be there. Okay, for a single copper tube, two fins will be there, this one and this one. Fine. So now let's calculate this. One. Write down what is given in the problem. The length of the fin, this is the half of the distance between the two tubes, that is 225 mm. It is equal to 0.225 meters. Temperature at the base of the fin. Temperature at the base of the fin. Let's see. देखो क्या दिया हुआ है. Steam at 100 degrees Celsius, saturation temperature condensed to water at 100 degrees Celsius passing through the copper. That means the base temperature 100 degrees Celsius. Now the temperature of the air, here it is given, air temperature 26 degrees Celsius. So this TA is 26 degrees Celsius. Now what else? After this, thermal conductivity is given and H is given. Thermal conductivity is this 48 and 48 watt per meter degree Celsius, and H is 25 watt per meter square degree Celsius. So thermal conductivity value I will write 48 watt per meter degree Celsius, and H is 25 watt per meter square degree Celsius. Now we have to find the first one, that is the heat loss per meter length of each tube. Let's see. Okay, so fine. So here you can see fin is having finite length. Okay, and here we have taken case 2, that is fin is having finite length and insulated at the tip. Okay, fin is having finite length and insulated at the tip. Fin is having finite length and insulated at the tip. So you can see we'll apply the heat dissipation expression. So it is equal to KAM T naught minus TA into 10 hyperbolic ml. But you can see the half distance will act as a fin, and for a single tube, 2 fins will be there. Okay. So each tube will have 2 fins, each having 250 length. So we'll multiply this by 2. So each will have 2 fins having length 250 multiply by 2. Let's calculate m. M is equal to root pH by Ka. Okay, so P क्या है? 2 times of B plus Y into H divided by K into B into Y. So put the values 2 into put कीजिए steel plate 1 mm thick.
Sir, 229.38 watt.
करेक्ट आंसर, वेरी गुड है ना. चलिए सॉल्व कर लेते हैं हम. Heat loss per meter length of each tube. Okay, so that is you can say here है ना, so that will be 1. यहाँ पर आपका ये जो B है आ जाएगा. थिकनेस कितना है? 1 mm. So it will be 0.001. H का वैल्यू क्या है आपका? 25 divided by thermal conductivity is given as 48 into 1 into 0.001. Let's calculate this. So calculate the value of M is 32.29. Now put the value for Q, for calculating Q. So Q is equal to K. So K is 48. Cross sectional area is 1 into 0.001. Okay. Into M that we have calculated 32.29. KAM into T naught minus TA. So T naught is 100. TA अपना कितना है? TA is given as 26 into 10 hyperbolic ml. So M is 32.29 into length is 0.225 है ना. 225 mm है, so 0.225. Okay, and you will multiply this factor by 2. So just calculate this. So Q is equal to 229.38 watt. Okay, 229.38 watt. Okay. So this is 229.38 watt per meter length of each tube. Per meter length of each tube. Okay, so we have determined the first one, that is the heat loss per meter length of each tube. Now we will find the mass of steam condensed per hour in the panel that contains 25 tubes. So that we will find. So here for the second one, the number of tubes is given as number of tubes, that is small n, is given 25. So we can say this, we know the number of tubes multiplied by heat dissipation from a single fin is equal to the total heat transfer. Okay, so the total heat transfer we will see what is given in the problem. The steam at 100 degrees Celsius saturation temperature condensed to water at 100 degrees Celsius passing through the copper tubes. Okay, so we will see the latent heat of this. Okay, so we will find the latent heat HFG. Okay, so at 100 degrees Celsius, so we'll get this latent heat at 100 degrees Celsius at 2257 kilojoule per kg at 100 degrees Celsius from the steam tables. Okay, so either the steam table will be provided to you or this problem will be mentioned in the problem itself. Okay, or the value will be mentioned in the problem itself. Either the steam table will be provided to you or the value will be mentioned in the problem itself. Okay, so this is the latent heat. This is what? This is latent heat. Okay, so latent heat is 2257 kilojoule per kg at 100 degrees Celsius from the steam table. Okay, so now just put this, find the value. So we can say this 2257.
सर वो मास पर आवर है, मतलब फिर क्या करना पड़ेगा फिर?
हाँ, उसमें कन्वर्जन कर लो उसे 1 आवर में कि कितना हो गया 3600 सेकंड्स है ना, तो उस हिसाब से आप कन्वर्जन कर लो, है ना। 2257
सर एक मिनट ऊपर स्क्रॉल कर सकते हो?
ठीक है, ओके। तो अभी हम क्या करते हैं इसमें, 2257 इज इक्वल टू नंबर ऑफ फिन्स आपका कितना है 25, हीट डिसिपेशन फ्रॉम द फिन कितना आ गया आपका, ये हमने ऑलरेडी कैलकुलेट किया हुआ है, 229.38 229.38। ओके, अभी ये किस में है आपका, ओके, सो दिस इज इन द जस्ट पुट द वैल्यूज, ये आपका वॉट में है, यानी कि जूल पर सेकंड में है, ठीक है, और ये जो वैल्यू है आपकी किलो जूल में। ओके, किलो जूल पर केजी है, दिस इज किलो जूल पर केजी। हाँ, 1000 का मल्टीप्लाई करना पड़ेगा, है ना, किलो जूल पर केजी। तो ये आपका हो जाएगा 1000 का इधर मल्टीप्लाई कर लो। ओके, और हमें जो ओके नाउ यू विल कैलकुलेट दिस। और अभी हमें क्या करना है, इसे वैल्यू किसमें फाइंड करना है, द मास ऑफ स्टीम कंडेंस्ड पर आवर। ओके, तो ये जो हमें वैल्यू मिल रही है ना, वो आप आर गेटिंग और नॉट? सो
हाँ सर।
है ना, अभी देखो ये क्या है, इसको थोड़ा क्लैरिफाई करके लिखो। देखो Q total is equal to this. Okay, and this, what is this Q total? This Q total is nothing but this is M into HFG. This is M into HFG. What is M? M is equal to this the mass of steam condensed. ठीक है, तो आपका ये जो टोटल है यहाँ पर आपका ना, एक बार मैं फिर से ही लिखता हूँ पूरा। एक देखो ये दिस इज QT जो है आपका, दिस इज
तो वो लेटेंट हीट
मास ऑफ,
मल्टीप्लाई करेंगे क्या?
ये लेटेंट हीट जो है आपको स्टीम टेबल दिया जाएगा, तो स्टीम टेबल से आप, है ना, वो जो टेम्परेचर दिया है सैचुरेशन टेम्परेचर 100 डिग्री सेल्सियस, उस पर यू कैन फाइंड द वैल्यू दिस HFG लेटेंट हीट। अदरवाइज इट विल बी डायरेक्टली गिवन इन द प्रॉब्लम। ठीक है, आपको फिर से लिखते हैं बेटर। के लिए total heat is equal to heat number of fins multiplied by the heat dissipation from the single fin. Okay, and this total heat is equal to what? Mass of steam condensed into the latent heat. So ultimately I can write this as number of fin multiplied by heat dissipation from a single fin is equal to mass of steam condensed into latent heat. ठीक है, so number of fins is 25, heat dissipation from a single fin is 229.38. It is equal to mass of the steam condensed that we have to determine, HFG latent heat 2257. अब ये किलो जूल पर केजी में है, तो जूल में करने के लिए 1000 से मल्टीप्लाई किया। अब ये जो m का वैल्यू मिलेगा दैट इज इन द केजी पर सेकंड। ओके, केजी पर सेकंड। सो 1 R is equal to 3600 second. Okay, 1 R is equal to 3600 second. So 1 second is equal to 1 upon 3600 R, है ना। तो ये केजी पर सेकंड में है, तो 1 R is equal to 3600 second. तो 1 second is equal to 1 upon 3600 R. तो यहाँ पर आप कर दोगे 1 upon 3600, तो वो 3600 ऊपर आ जाएगा। ओके, तो यहाँ पर मल्टीप्लाई हो जाएगा 3600। So finally you can calculate mass of steam condensed is equal to 25 into 229.38 into 3600 divided by 2257 into 1000. So in this way we can calculate this mass of steam condensed per hour. So mass of calculated value is, calculated answer is 9.146 kg per hour. So this is the answer. So this is the mass of steam condensed per hour. Okay. So let's solve. Okay, so we have solved this problem. So we have determined the heat loss per meter length of each tube, and we have determined the mass of steam condensed per hour. ठीक है, अभी ये वाला प्रॉब्लम सॉल्व करते हैं। 8th प्रॉब्लम, अ लॉन्गिट्यूडनल।
इसमें सर वो फॉर्मूला ही था ना सर, आपने जो कल बताया था इफेक्टिवनेस का, अभी के इसमें
अभी में हमने इफेक्टिवनेस कैलकुलेट नहीं किया अभी।
नहीं सर,
हाँ
वो जो अभी
अभी
हम सॉल्व किया,
हाँ
उसमें फर्स्ट केस में हम लोग ने हीट लॉस निकाला, अब हम लोग ने उसको इंटू टू क्यों किया मतलब?
इंटू टू इसलिए किया कि देखो यहाँ पर क्या है कि देखो दो ट्यूब्स हैं, तो टू ट्यूब्स के बीच डिस्टेंस कितना है, 450 mm है ना। तो मिड पॉइंट जो है वो कोल्डेस्ट पॉइंट होगा, एंड यहाँ पर टेम्परेचर ग्रेडियंट 0 होगा। सो जो हाफ ऑफ द डिस्टेंस बिटवीन द टू ट्यूब है, इट विल एक्ट एज अ फिन। ओके, तो एक ट्यूब के लिए इधर भी
ओके
225 है, इधर भी 225, तो एक ट्यूब के लिए दो फिन्स होंगे, ये फिन और ये फिन, इसलिए 2 का मल्टीप्लाई किया है। अंडरस्टूड?
ओके ओके सर।
चलिए अभी हम ये वाला प्रॉब्लम सॉल्व करेंगे। 8th वन, अ लॉन्गिट्यूडनल कॉपर फिन थर्मल कंडक्टिविटी इज गिवन 600 mm long and 5 mm diameter is exposed to air stream at 20 degrees Celsius. The convective heat transfer coefficient is given as 20 watt per meter square degree Celsius. If the fin base temperature is 150 degrees Celsius, now determine the heat transfer and the efficiency of the fin. सॉल्व कीजिए वाला प्रॉब्लम, बहुत सिंपल है। Let's solve the problem 8. Okay, so in the problem, let's write down what is copper fin. Activity is given. The length is given. Okay. Length is given as.
Sir, you are not audible.
Yes. Now, can you hear me?
Yes, sir.
Okay. So length of the fin is 600 mm. It is given in the problem. So that means it is 0.6 meters. Okay. Now the diameter of the fin is given as 5 mm. So 5 mm. So it is equal to 0.005 meters. Fine. Now the fin base temperature. Okay, fin base temperature is given. कितना दिया है fin base temperature? Fin base temperature is 150 degrees Celsius. Now the air stream temperature is given as this is exposed to air stream at 20 degrees Celsius. So air stream temperature, that is the ambient temperature, is given as 20 degrees Celsius. ठीक है? Now the thermal conductivity is given as कितना दिया है? 380 watt per meter degree Celsius. And the value of H is given as convective transfer coefficient is given as 20 watt per meter square degree Celsius. Okay. Now what we have to find? Heat transfer and efficiency of the fin. Okay, so now you can see here the length is given as 0.6 meters. Okay, so here you can say the case 2 is the suitable choice. So we'll take case 2. Fin is having finite length and insulated at the tip. Okay, so let's apply the expression for calculating heat dissipation. So it is equal to Q is equal to K AM T naught minus TA into 10 hyperbolic ml. So let's calculate m first. M is equal to root pH by Ka. So P is what? Perimeter will be equal to, this fin is having circular cross section 5 mm diameter. So perimeter will be equal to pi d. Okay, and this will be H divided by thermal conductivity. Cross sectional area will be pi by 4 d square. So pi cancel. This d will cancel. So we'll get this as 2 root H divided by KD. ठीक है. So 2 root H का वैल्यू कितना है 20 डिवाइडेड बाय K का वैल्यू है 380 into diameter is 5 mm, so that means 0.005 meters. Value put कीजिए. So calculated value of m is 6.49. ठीक है. Now we'll put all the values in the above expression for calculating Q. So Q is equal to K 380 into cross sectional area pi by 4 into d square. D कितना है 0.005 स्क्वायर इंटू m. m हमने कैलकुलेट कर लिया 6.49 इंटू टी नॉट माइनस टी ए. टी नॉट अपना कितना है 150. टी ए कितना है 20 इंटू 10 hyperbolic ml. m is 6.49 into l is लेंथ कितना दिया हुआ है 600 mm, that is 0.6 meters. Okay, so हमने सभी values put कर दी हैं. Just calculate this. So the calculated value of Q is 6.29 watt. Okay, so heat transferred we have calculated. Now we have to calculate efficiency of the fin. Expression for calculating the efficiency of the fin is, okay, now we'll calculate second one. The expression for calculating the efficiency of the fin for the case 2 is, that fin is having finite length and insulated at the tip. So the for case 2, the expression for calculating efficiency is 10 hyperbolic ml divided by ml. Just put the values. 10 hyperbolic m is 6.49 into L is 0.6 meters divided by M 6.49 into L, that is 0.6. So just calculate this. So the answer is 0.2566. That means the efficiency is, okay, multiply by 100. So that means the efficiency is 25.66%. Okay, so this is the answer. Fine. Now let's solve another problem. This one, ninth one. Let's read the problem. I am providing you a single minute. Okay. So just okay. So this is the last problem of this set. Okay. So okay. So problem 9. Okay. So just read the problem. A steel rod having thermal conductivity 32 watt per meter degree Celsius, 12 mm in diameter and 60 mm long, with an insulated end, is to be used as a spine. That means it will be used as a fin. It is exposed to surrounding with a temperature of 60 degrees Celsius and a heat transfer coefficient of 55 watt per meter square degree Celsius. The temperature at the base of the fin is 95 degrees Celsius. Okay, now we have to determine the fin efficiency, temperature at the edge of the spine, and the heat dissipation. So you just see this. A steel rod thermal conductivity given 12 mm in diameter and 60 mm long with an insulated end. That means it is clearly given in the problem that, okay, this is a case 2 problem. Fin is insulated at the end. Okay, now we have to solve this problem by taking case 2 only, because it is clearly mentioned in the problem that it is case 2. That is, fin is insulated at the tip or the end. That's all. Problem 9. So first of all, write down what is given in the problem. So the diameter of the fin is given. So diameter is 12 mm. That means it is 0.012 meters. The length is 60 mm. So it is equal to 0.06 meters. Okay, now uh, it is exposed to the surrounding with a temperature of 60 degrees Celsius. That means the surrounding temperature or the ambient temperature is 60 degrees Celsius. And heat transfer coefficient of 55 watt per meter square degree Celsius. That is H is equal to 55 watt per meter square degree Celsius. Temperature at the base of the fan is 95 degrees Celsius, so T naught is 95 degrees Celsius. Now we have to determine to find. First one is the fin efficiency. Second one, we have to find the temperature at the edge of the fin. The temperature at the edge of the fin means temperature at the tip or the edge of the fin. That means temperature at x is equal to L. That means since we have to find the temperature at the edge of the fin. Okay, we have to find the temperature at the edge of the fin, so x will be equal to L. This we have to determine. And third one is the heat dissipation. This we have to find. Now solve this. First one, the fin efficiency. So for case 2 is given in the problem. That means fin is having finite length and insulated with the insulated end. Okay. Fin is having finite length with insulated end. So let's see. So for the second case, fin is having fin with insulated end, the expression for calculating efficiency is 10 hyperbolic ml divided by ml. So we will calculate m. M is equal to root pH by Ka. So it is equal to, again, this is having diameter 12 mm. So this is the fin having circular cross section. So perimeter will be pi d. This is H divided by thermal conductivity into cross sectional area will be pi by 4 d square. So again pi cancel, this d will cancel. So we'll get this as 2 root H by Kd. So just put the values. 2 root H is 55 divided by thermal conductivity is given as 32. Okay, and the diameter is 12 mm diameter, so it is 0.012 meters. Just calculate this. So the calculated value of m is 23.93 per meter. Okay, now you calculate the fin efficiency. So it is equal to 10 hyperbolic. M is 23.93 into L. The value of L is, L का वैल्यू कितना दिया हुआ है, 60 mm long. So it will be equal to 0.06 meters divided by 23.93 into 0.06. Just calculate this. So the calculated value is 0.6218. That means the efficiency value is 62.18%. Okay, now we'll calculate the temperature at the edge of the spine. That means temperature at the tip of the spine. So for second case, the mathematical expression for calculating temperature, mathematical expression for the temperature distribution for the second case is theta by theta naught is equal to T minus TA divided by T naught minus TA. It is equal to cos hyperbolic m L minus x divided by cos hyperbolic ml. Now we have to find the temperature at the edge of the spine. So T at x is equal to L minus TA divided by T naught minus TA. It is equal to, now x is equal to L. So L minus L is 0. So cos hyperbolic 0 is 1. So 1 upon cos hyperbolic ml. I'll just solve this. So temperature at x is equal to L minus TA. TA is 60. Just see this. What is TA? Surrounding with the temperature 60 degrees Celsius. Okay. We have written this. T is 60. Fine. T naught is 95 degrees Celsius. So T is 60. T naught is 95 minus T is 60. It is equal to 1 upon cos hyperbolic ml. M is 23.93 into L is 60 mm, that is 0.06. Okay, so just solve this. We'll get one equation and the only unknown is T. Okay, so in this way we can calculate T at x is equal to L. Okay, just solve this. Simplify, just solve this. So we'll get one equation in terms of t at x is equal to L. So we have one equation, one unknown, that is t at x is equal to L. We can find this. So t at x is equal to L. I calculated L is 75.75 degrees Celsius. Okay. Now the third one, we have to calculate heat dissipation. We have to calculate heat dissipation. So, okay, very straightforward, very simple. Just apply the expression for calculating heat dissipation. So expression for calculating heat dissipation for this is KAM into T naught minus TA into 10 hyperbolic ml. So Q is equal to K. The value of K is 32. Cross sectional area is pi by 4 d square. So pi by 4 d square. D is 12 mm. That is 0.012 meter square. Into M. Calculated value of M is 23.93 into T naught. T naught is 95 degrees Celsius minus TA. TA is 60 degrees Celsius into 10 hyperbolic M. Value of M is 23.93 into L. L is 60 mm, that is 0.06 meters. Okay, so we have put all. Okay, so we have put all the values. Just calculate this. So the calculated value of Q is 2.7 and the unit is watt. Okay, so this is the heat dissipation. Okay, so we have solved the problem. So we have calculated the fin efficiency, temperature at the edge of the spine or fin, and the third one, that is the heat dissipation. Okay, for this problem. Okay, so we have solved this this last problem of this problem set. So we have solved all the problems of this problem set on fins.
सर ये डॉक्यूमेंट शेयर कर दीजिए.
हाँ हाँ, मैं डॉक्यूमेंट भी शेयर कर देता हूँ एंड मैं रिकॉर्डिंग भी शेयर कर देता हूँ. ओके
ओके सर.
ओके, सो डू यू हैव एनी डाउट, एनी क्वेरी?
नो सर.
ओके फाइन.
सर अटेंडेंस.
मिनट. हाँ
अटेंडेंस.
यस यस. हाँ हाँ करेक्ट. Just give me a minute. Let me download attendance.